All right, so for part B, we want to implement this build method, which is basically quicksort, but on BST and using LL node. So what is it going to take in? It's going to take in a node, okay? And that is going to help us with creating our BST. It's going to contain all the values that we need to put into our BST. And this pivot P is going to determine what type of pivot we want to choose. So we have three options for the pivot based on this enum class. And what is an enum class? It's actually a special class. And it represents constants, so kind of like final variables, right? So if you see this example, low, medium, high, like these are the variables that are inside this class. And then if you want to access them, you need to access with the class name first, followed by a period, and then the name of the enum constant. So it's a dot syntax. And if you run this, what you get, right, if you just print out my var, you're gonna get medium, okay? So in our example, we're using first, random, and median to denote what type of pivot we want to do. And then depending on that, we'll split off into different cases, right? So first, we need to fill out the return type of this method. It's going to resemble a BST, which means that we want to return a tree node, right? Because the BST is made of tree nodes. And then if P is pivot.random, then we need to use the method that we created in part A, which was choose random pivot, to set our pivot to be something random. And what is that going to take in? It's going to take in a LL node, right? And that is going to be our node that we pass into this function. Okay, and note that pivot is declared right there, so we just need to set it. Else, if it's pivot dot first, in other words, we're choosing the first element to be our pivot, then that's really just the item in the first node. And otherwise, we call choose median pivot, which will be, which has been implemented but not shown to us. Okay, and after we do that, now what are we trying to do with the while loop? So the while loop is going to be the traversal of our array, of our linked list, not array, to see whether each element is going to be on the left side of the pivot, smaller than, or on the right side, greater than the pivot. Okay, so as long as we're able to traverse, as long as node is not equal to null, okay, here we're doing left, right? So that tells us in what order the if and the else if case should come in. So left is all the elements that are smaller than the pivot. So if node dot item is less than the pivot, then what is left going to be? Well, we're trying to build these left and right LL nodes, right? And also their names are pretty helpful. So it makes sense that we're going to create a new LL node. And what do we need to pass into an LL node? If you refer to the top of the question, LL nodes are going to take in an int item, the constructor, and then the LL node next. Okay, so we know the item is going to be just node.item. Okay, whoops. And what is going to be the next? Well, the next is whatever is right now the left, right? Right now, we're in the very beginning, we're going to start off with null. But then afterwards, as we grow our list, we're just going to be adding nodes to the beginning, right? And so that's going to be left. And same thing for the right. So if node.item is greater than, whoops, than the pivot, then right is going to be a new LL node with node.item and right. Okay? Okay, and then because our while loop condition is whether node is not equal to null, we have to update node every single iteration. And so that is going to look like, let me scroll this up a little bit. That is going to look like node equals node. Oh no. Well, I was about to run out of room anyway. So let me go back. This is going to be node equals node dot next. Okay. Or sorry, I should be writing here. Node inside the while loop. Node equals node dot next. So this is the updating part. And then what happens outside the while loop? So now that we have these left and right arrays, all we need to do is recurse, right? So we know that we have to return a tree node. Okay, so we probably need to make a new tree node. And what is a tree node going to take in? Well, if you look back at the constructor or the class defined at the top, the constructor takes in item, tree node left, and tree node right. Okay, so what is the item in this case? Well, the item is going to be the pivot. Okay. Right, because remember for a BST, if this is my root, everything here, right, to the left of me is smaller than me, and everything to the right of me is greater than me. That is exactly like in quicksort, where everything to the left of me is less than, and everything to the right of me is greater than the pivot, right? Okay, so with that analogy, let's continue on. So the item is going to be pivot, and what's going to be my left child? Well, it has to be a tree node type. Okay, well, what is it? What method is going to return a tree node type? Okay, well, it is this method that I'm using here, and I know that I have to recurse. So I'm going to be calling build. But build is going to take in an LL node and a pivot P, right? And so it's going to have to take in left, and then P is going to say the same. So whether we are using left, median, or random for a pivot is going to stay the same, consistent throughout our algorithm. And then for our right, it's going to be the exact same thing, except now we need to pass in the right LL list. Okay, so this is going to be our new tree node, and we just need to return it.